our argument has been translated into a well-formed formula with I implies H and F or not H, F or not H, and I implies F. The first hypothesis is here, I implies H. The second hypothesis, so this is basically our first hypothesis, and we're going to refer to it actually as just as one. Our second hypothesis we might refer as number 2, and the third hypothesis is this here, number 3. So this is basically like a little puzzle. We try to get all these expressions transformed so that at the end we come to the conclusion of F. That's what we want to prove. So we're looking for pattern. One that strikes out is actually number 2. If you look at this here, F or not H, it looks quite familiar. We can actually take this here, and I'm just drawing this out. We can take this here and just write it. We could write it also as not H or F. And what we do is we take the second hypothesis and we use the commutative law, which basically just swaps them out. And of course, as we can maybe remember, not H or F could actually be seen as H implies F. These are two equivalent formats. If we have that, we can actually now combine what we have here. So we take this plus the first hypothesis. If we take this whole section here, we can read this actually as I implies H and H implies F. There's another inference rule, the hypothetical syllogism, that says that this particular expression can actually be substituted with I implies F. And that makes sense. So if H is the conclusion of I, and then becomes the premise of for F, for H implies F, then we can basically, if I implies H and H implies F, then naturally I implies F. And of course, at any time we could prove again if this is a valid inference rule. So, but what we have done so far is we reduced the big circle here with these stats to I implies F. And then what is left is our and I here. So we need to bring this down to and I. Now what we have is a traditional modus ponens. P and P implies Q produces Q. Using the modus ponens, we actually come to the conclusion that if I implies F and I, then produces F. And that's exactly what we want to show here. So we have proof that this is a valid argument.